Alright, so we're going to go over these. This is called an inscribed angle. First we talked about central angles, now we're going to talk about inscribed. If you remember this is an angle who's on the circle or inside the circle. So you can see this inscribed angle we're talking about is X. Now when we talk about central angles, the angles and the arcs were exactly the same. Now inscribed angles can be a little different. You can see here that the inscribed angle will be half of what the arc is. Or vice versa. The arc will be double the angle. So if we're looking at this picture on the right that I've been circling, if this is 82, this is simply 41. And I got that because it's half. Always can think of this as this being the smaller angle and this being the bigger arc. So inscribed angles, the angle here is half of the intercepted arc. Intercepted arc being from A to C. Alright, another theorem we have to talk about. This doesn't really have a name, but it says here if an inscribed angle, which is our C, if the endpoint, so if it, see how it's going from C to A and C to B, if you notice from A to B right here, this little dotted line, that's called the diameter. If you remember from class, we talked about semicircles. A diameter creates a semicircle. So if you remember, a circle is 360, and then a semicircle creates 180 degrees. We talked about that in central angles. So you can see that if I were to relate what I just talked about in my last slide, this is 180. And since this is my inscribed angle, I have 180 is 90. So no matter what, this angle could have been over here for all that matters. Or even over here. Anywhere it needs to be. But as long as the endpoints are on the diameter, it's always a right angle. So that's going to come into play. Alright, another theorem or kind of thing that I want to make sure we touch on before we start jumping into examples. You can see here, if I look at this picture, you can see C and D are both inscribed angles because they're on the circle. If I were to follow C, so look here, if I follow, let me do different colors so you can see nice and pretty. If I follow C, this line right here, it goes to B and it goes to A. But if I follow D, it also goes to A and also goes to B. So you can see angle C and angle D both go to the same arc. Which if they go to the same arc, that means C and D have to be congruent. That's what this is talking about. If they converge onto the same arc, that means the two separate angles have to be congruent. That's what this is talking about. And we're going to apply this to some problems. Alright, so we're going to just work on some very basic definition or examples. First, move our way up. Alright, so remember we're talking about inscribed angles. Angles that are on the circle. So, the way to help me is this is always the small angle. This is always the big one. So in the left one, I'm going from big to small. And if you remember, inscribed angles are either you times by 2 or divide by 2. If you can remember those two things, you're going to be in good shape. So if you can see here, there's no way I would multiply 70 by 2 and get this little guy to be 140. That would make no sense. But in this one, we're going to take 70 and cut it in half. And my answer to this would be 35 degrees. There we go. Alright, let's shift to the right one. So you can see here, if I have 85, that's this one right here. Follow my lines, that's V, that's W, we're talking about this arc right there. So we're going from small to big. So I'm going to take 85 times 2, and I'm going to get 170 degrees, and that's my answer. Alright, so you can see sometimes problems can get very complicated very fast, and they may seem complicated, but they're really not. They might put extra lines in there to kind of confuse you, but it's really not that hard. So this left one right here is this angle right here. So let's follow. Let's see how hard this one is. Let's follow my lines. I'm going to follow this to here and this to here. That means we're talking about this arc here, which is exactly what they're asking us. Now they put this line in, this line in, and this line in to try to confuse you. That's just too much. So what you need to do is, once again, all we're going from small to big. We're going to times by 2. So 35 times 2 equals 70. So that's my answer, 70 degrees. Now on the right one, we're given 46. Let's follow my lines from Y to here and Y, oops, Z, and then we're talking about this arc. So this line doesn't mean anything. So we're going from small to big again. Taking 46 times 2. Be 92 degrees. And there you go. So nothing too hard. If you follow your angles and know what you have and know what you need, you're in good shape. Don't be confused so easily. Alright, once again, follow your lines. We'll go from here and here, and there's the line we're looking for. Once again, they gave you too much information. You don't need all that. So we're just simply going from big angle to small angle. So we're just dividing by 2. This means my answer to the left one is just simply 60. Over here, this is this angle right here, so let's just follow my lines right here and right there, even though it's bad. I'm talking about this angle here, so you can see once again, too many extra lines. We should take 31 times 2 and get 62 degrees. So there you go. Nothing too complicated. Alright, so this is when things get a little difficult, but nothing too bad. You always got to know what you have and what you can use. You're going to use a lot of different things that we've talked about in the previous. So first thing right here, I have a triangle over here. You can see there's my triangle. I need to know this. That's what I need to know. But if I look at my line, I got right here and right here. This arc that I'm trying to find actually goes with this guy right there. So they go together. So whatever I find for x, all I have to do is double it to find the question mark. So if you remember, this is why I tell you got to remember things from previous units. If I look at a triangle, if you remember, well, how much does a triangle have to add up to? Is it 360? Is it 90? No, it's 180. So if I know two angles in a triangle, it's not even a right triangle. It's not, because I don't have a 90. All I have to do is take 180 minus 80, and then minus 35. So it'll be 65 degrees. So that means x is 65. Not my answer. This is 65. And what we talked about before, if I just follow my lines, it goes to my answer. So all I got to do is multiply by 2. 130. So you can see we have to do one thing in order to do the next. Now another thing I could have done, if you realize this, is figured out that this is 70 because I'm going to follow my lines here. 35 becomes here. And 80, this big one on the right here, is going to be 160. I got those numbers by multiplying 80 times 2 and 75 times 2. Now if I take 75 plus 160 and then subtract it from 360, because all three of these have to add up to 360, if you took 360 minus 160 and 70, I can guarantee you're going to get 130. So you can see there's multiple ways to do it. It's all about what you see. One person can do it the way I did the first way. Someone else can do it the 360 way. It's up to you. Alright, let's look here. The first thing I was identifying in a problem, guys, is that I have a diameter, which means 180 degrees should come into play. And then I look at what I'm given. Okay, I'm given 156. You see that does not go with it. This goes with this little angle here. Not helping. But if I look here, 56 goes right here. Okay, let's just do what I know. 56 times 2 is 112. Okay, so wait, let's go back to this diameter concept. Okay, if I do this, there's only two arcs to the left. There's a question mark, 112. If you remember, a semicircle has to add up to 180. So that means those have to add up to 180. So all I got to do is subtract. There's my answer, 68 degrees. So guys, just do what you know. Know that they have to add up to 180. Know that, okay, I got 56. I know this arc is 112. And I'm like, okay, look, I have here. Do what you know, and it's going to figure out what you need and how to do it. Alright, so let's go over these two problems. Okay, so first one on the left. Okay, so I always look at what I know and what I need to know. So 138. Okay, I have no diameter, so that means I can't do 180. I have 138, but look here. There's no one angle that it goes to, like here. See how everything goes to K? We can't do that in this one. It's not going to one angle. But look right here, I have 113. If I follow these lines here and here, 113's intercepted arc goes from here all the way around. It goes all the way. That's where 113 comes from. Right there, you can see that. Oops. But if you guys notice, I already know from here all the way to here. Okay, first let's find the whole yellow arc. The whole yellow arc is 226. That's 113 times 2. If I know that part of this is 138, and I'm looking for this, all I should have to do is take 226 minus 138. That's my answer, 88. And that's the way we can do it. Now I just took what I knew and put together some pieces. It wasn't that much. We're going to kind of do the same thing over here. Now look, first thing you should get in a problem is, okay, we have a triangle. So we could use the fact that they add up to 180, but I don't know anything. I know this, but I don't know another one. I don't know enough. Also, look right here. The moment it crosses here, that means I'm going to use 180. Okay, let's try to apply that. Okay, this is 96. Okay, then we can figure this out to be 104. I got 104 because I took 180 minus 96. Okay, good. And then I can take half of that and get 52. There you go. That's one way to do it. if you remember this, I think it was the second slide I went over, I told you that if an inscribed angle's endpoints are on the diameter, that automatically means it's a right angle. Automatically. There's no question. But I got a right angle there. So I can figure out this angle here by taking half of 96. Half of 96 is 40... Oof. It's 45... 48, sorry. That's what happens when you do stuff here. So that means you can do one of two things. You can add all three of these up and subtract from 180, or you take 90 minus 48. 52. I get the same answer. So that's how you apply different things. I figured out I did two different things. So that's how you do it. Alright, so let's go over these. So we got two problems. The one on the left, you can see we have a diameter. So there's a chance that we're going to use 180. Okay, so we know we're looking for that. Okay, so when we do a problem, always do one thing at a time. Okay, I got 53. So follow my lines here to H and G. Okay, I could find this arc right here by just doubling 53. Okay, that's 106. Now we can start looking at that diameter, guys. I have from H all the way to F. That is what we call a semicircle. So that means this plus that, this guy plus this guy equals 180. So that means 180 minus 106. And then that's going to give me 74. Sounds about right. And there you go. That's it. Knowing one thing, doing little things at a time is getting us closer to the answer. Alright, this one right here. We can't use the 180 concept because there's nothing going through the circle, or the center, sorry. But look right here. I have 1, 2, and 3 arcs. All three of them have to add up to 360. Now I know we don't have this number, but we can easily find it. Because if you go from here to here, that's this arc right here. So from H all the way to G is 200. If you didn't know where I got 200, I just doubled the 100. So all three of these have to add up to 360. So if I just take 360 minus 255, I just quickly added those two up pretty quick. I'm going to get 5, that's 0, 105. There you go. So simple rules that I know based on circles helping me out tremendously in these problems. Alright, problem like this. We have a triangle here, but if you notice that there's only 3 arcs. There's the 10x, the 7x, and the 9x. So you should think, okay, all 3 of them must add up to 360. So let's figure it out. Let's add them up. So 10 plus 9 plus 7. Okay, that's going to be 26x. I just did it all in my head. If you want to write 10x minus 10, 7x plus 18, plus 9x minus 12, you do that. And then you get 36. But I'm just doing it pretty quick. It's going to be subtracted by, let's add those up. I just want to make sure I get them all right. Minus 10, minus 12. It's going to be minus 4 equals 360. So this is what I get after I combine like terms. That's what I did. So I'm going to take 26x equals 364 because I add that 4 over. And then all I'm going to do is divide. Divide both sides by 26. That's x equals 14. Now make sure to pay attention to what the problem is asking you. You could simply ask for one of the angle measurements and like that. But one question I want to ask in this one, it's important to know. Classify the triangle. I want to answer that question. Hopefully you guys are watching this because that's an important question that you have to understand. Classify it. Tell me, you have 3 types of triangles. You have equilateral when they're all the same. You have a scalene when they're all different, and isosceles when 2 are the same. So you can't look at this and justify it. What you must do is type 14 in and type in for every single one. So I'm going to do that on my own. You should be doing that too. This one gives me 130 degrees. This gives me 116. And then the last one gives me 114. So you can see they're close, but they're all different. So that means this is a scalene. And the reason it's a scalene is because none of them are the same. If these two came out the same, be an isosceles. If they all came out to be the same, be an equilateral. Because equal means the same, lateral means side. So that's just another tip for you guys. This will come up on quizzes and exams. Just FYI. Hopefully you guys watch this. Good talk. Alright, so let's go over this. So we have 50. We do have a diameter here. We'll see if that 180 comes into play. It might not. May or may not. I don't know. So there it is right here. So that means 55 goes with 56x plus 2, but I can't. But 55 is not equal to 50x minus 2. It's actually double 55. So 55 times 2 is 110. Equals 56x minus 2. So you can see that's what it is. That's how I'm going to make them equal to each other. Just like back in central angles when we had this, we'd set them equal. But they're not. It's this times 2 gives me that. So now I'm going to add 2 to both sides. And I'm going to get 112 equals 56x. And that's going to give me x equals 2. So that means x equal to 2. Oops. Alright, so we're going to work on this one. Now, I'm just going to show you what I think when I go through a problem like this. You guys can do whatever, as long as it gets the right answer. So, we know from here to here is 146. I know this from here to here is 60. So, I know that this is 7x. So, usually what I try to do is if there's an inscribed angle, I try to make it an arc, my intercepted arc. So, if you guys realize, if I follow the arcs, or the chords, this is my intercepted arc right there, the one that I do not know. So 7x times 2, what's 7x times 2? Well, that's 14x. So that yellow part is 14x. Pretty much everything else is 146 and 60, which is 206. Quick math in my head. So that means 206, if you don't agree with me, plug in a calculator to get the right thing. And 14x, they add up the whole circle. The whole circle has to be 360. So we're going to subtract 206 from both sides. We get 360 minus 206, and we get 154. We're going to divide by 14 from both sides, and we're going to get x equals 11. So that's my answer. So you can see, guys, we use definitions and theorems to figure out how to do the problem. Alright, so you're going to kind of see, guys, a lot of problems happen more than once. So we've seen a problem like this back a few slides ago. So what I'm going to do is the same way we did it before. We realize that this plus whatever this is going to be 360. We know that. We've done a problem like that. We're going to take 125 plus 65 plus something. But instead of now we have a thing like here. We have to multiply by 2. So pretty much we're doing 15x minus 5 multiplied by 2, which means we have to distribute. So it's going to be 30x minus 10. All I did was distribute 15 times 2 and 2 times negative 5. So let's combine like terms. I get 30x plus 125, 190, 180 equals 360. I got 180 because I took 65 minus 125. That got me 190. I subtracted 10, got 180. I get 30x equals 180. I get x equals 6. There we go. So once again, prior knowledge with problems that we've done in the past is using to get harder problems. Same concept, just a little bit harder. Alright, so with these problems, we're going to kind of combine inscribed angles and central angles to kind of figure it out. So, first, let's look at this picture right here. The 32. I'm going to use what we know to find what we're given. If I follow from D to A and D to B, we're going to get this arc right here. That should be 64. You should know that right away. Now, if you remember, central angles are the same. So if this is 64, that means this has to be 64. So x equals 64. It's pretty simple. You got to know inscribed and central. Central angles are the same. Inscribed angles cut in half. That's a good way to think about it. Central angles same. Inscribed angles in half. All right, next. Oops. Alright, so once again, we are combining inscribed angles and central angles. So let's start with the one on the left. So if this is 162, we know from this arc here, it also has to be 162. We just know that. And in inscribed angles, you can see x goes to 162. It's inscribed angles. So all we have to do is take 162, cut it in half, and that's 81 degrees. Pretty simple. Now the one on the right, we're going backwards, just like the first one we did on the last slide, 51. That means this is 102. If this is 102, that's 102. So my answer to the left one is 102 degrees. Very simple. Alright, so this is a more complex problem. Various things going on here. But first, let's kind of break it down. What we have 32 degrees right here, and we have 116. So we are combining central angles and inscribed angles. So one thing you notice that we have a couple diameters, which means we're probably going to use 180 possibly at this point. And also, you can see here we have a vertical angle. So if this is 116, I can help you. It's 116. I know that. So if this is this right here is 32, which makes this 64. If you guys notice, one of the first few slides in this section we talked about if two angles go to the same intersected side, arc I mean. So like A, for example, you can see that it's going to B and C, the same one that D went to. So if this is 64, this is going to be 32. Okay? So what that means is that these three have to add up to 180. So I have a triangle that's like 180 minus 116 minus 32. So if we take 180 minus 116 minus 32, the answer is going to be 32. Alright, so that's one way to do it. I'm going to show you a different way to do it. Alright, so if I know that this is 116, that means I know from here to here is also 116. And also, if I know that A all the way to C has to give me 180, let's figure this out. Take 180. Actually, let's just do this. 180 minus 116. It gives me 4. It gives me 64. That's 64. This arc here. That means if I want to go to here, I just cut in half and I get 32 again. So I just showed you two ways. There's multiple ways to do a problem, guys. I'm not showing you one way to do a problem. Do notice that there are multiple ways to do a problem. Just because you do it one way doesn't mean it's the only way. Don't always get stuck on what's the one way to do it. There's multiple ways to do it.